This is Sandra K. Webster, and this video is going to demonstrate how to calculate a one-way ANOVA for between subjects using Excel. I'm starting off with a problem that I used on a final a few years ago. One theory of memory is that memory is stronger for items that have been connected to more items in a neural network. A test of this theory was devised by having Chinese language students complete exercises in which they were given a set of 12 new vocabulary words. Students were randomly assigned to complete one of 3 different homework assignments. This sentence in the problem tells us the design. We have 3 conditions, and we have different people in each one. They are independent. We can't do independent samples t-test because that would increase our chance of making a type 1 error. We'd have to do 3 of them, and that would be the wrong way to do it. So in this problem, we need to do an analysis of variance, and it's between groups. So reading the rest of the problem so we get the context. Students in the minimal network condition were instructed to write sentences that linked each word with another one of the words on the list for a total of 6 sentences with 2 words per net. Students in the moderate network condition were instructed to write sentences that linked 3 of the words on the list for a total of 4 sentences with 3 words per net. And the third group of students were instructed to link 4 words together in sentences, 3 sentences with 4 words each. A week later, the students were tested on their memory of the 12 Chinese words. The data are below, and I've got the data right here. Now, in order to analyze this with Excel, I need to get the data into Excel. So the first thing I'm going to do is copy it over. And I'm moving over to Excel. And I'm just going to put the data in. Paste. And I've got it. And it's all there. Now, in order for me to calculate a one-way between subjects ANOVA, I'm going to use the data analysis statistics package in Excel. And I'm going to basically move over to data analysis. And there's this ANOVA single factor. That is a one-way between subjects ANOVA. So I'm selecting it, and I say, okay, I have to select my input range. I select all of this. And it's by columns. My labels are in the first row. I want my output to be in a different place. And so right now it's got the output going to be in F1. And that's a good place for it, so I'm going to leave it that way. Just say OK. And we have analysis of variance results. Let's pull it out so we can see the words. I had rather long names for my groups, but there they are. There were 10 in each group. We always look at the descriptive statistics first. The sum was used to compute the ANOVA, but what we're interested in are the means. So first of all, let's think about the hypothesis. The stronger the networking, the better the memory. The strong net did have the highest memory. That was 8.9 out of 12 words on average, 7.7 and 5.8. Are these differences sufficient to be statistically significant? Well, they're compared to the variance, and analysis of variance uses the within subjects variance compared to the between groups variance to compute this F score. So this table shows us the analysis of variance summary table between groups. That would have to do with our independent variable, the amount of net connections, the within groups, within all, and then the total. Here is the F value. Here is its probability. That's a two-tailed probability. The degrees of freedom that you have to report are right there. So that's basically how we would compute a between subjects one-factor analysis of variance. The next video I'm going to do will show how will we determine which of these are statistically significantly different. Because just because we have a significant F, we don't know which of these means are really different from each other. They may each be different from all the rest, or maybe only one of them is different from the rest. And so we need to do multiple comparisons, and we'll do that in the next video.